we now have a numerical solution to our mathematical model. So let's move on to post-processing. If I go back to the framework that I introduced earlier, what we have now from the numerical solution are selected variables at selected points. In particular, we have two components of velocity and pressure at the cell centers. And we are going to do the post-processing, so everything is going to be calculated from those selected variables at selected points. We can do the post-processing within Fluent, and that would be over here in these menus. And we did a little bit of that when we were trying to understand, for instance, what happens when you initialize the solution and so on. There's also a full-featured post-processor called CFD Post, and we will use that since it has more post-processing capabilities than the inbuilt post-processor. So I'll exit from a close Fluent, and I'll go back to the project page, and I'll start the post-processor CFD Post by double-clicking on results. And CFD Post, the post-processor, brings in entities always as 3D. So what it's done is it's taken our 2D plane and it's revolved it about the axis, because this is an axisymmetric problem. To see that, so you can, first of all, to manipulate the views, if I just want to look along Z, I just click on Z, or I can go back to the isometric view by clicking over here. And if I zoom in using the right mouse button, okay, that gives me a closer view, and you can see the name selections that come in, but you also have this periodic one here. Let's see what that is. If I highlight periodic one, it shows me that it's this front surface. If I deselect that and select periodic one shadow, it's that back face. So it's basically taken that plane and it's revolved it by a small angle about the axis. And because of the axisymmetric assumption, whether we look at the solution on periodic one and periodic one shadow, it's the same. So we'll just look at the solution along periodic one. So I'll just deselect all these surfaces and go back to the view along Z. And for a 2D problem, we can just look at that view.